This lesson builds off of last lesson where we learned that the gradient of a curve at a point is the same thing as finding the slope of the tangent line through that point of the curve. And so what we'll talk about in this one is we'll talk a little bit more about the tangent line and introducing a new concept called the normal line. So let's go back to hopefully what is a familiar problem. Only the language is slightly changed. Instead of finding the slope of the tangent line to this curve at this point, we're going to find the full equation of the tangent line. And recall from linear algebra that the slope of a line is, you need two pieces. You need the slope and the slope intercept. So as we proceed through this example, you'll see that. So here's our function. Since we're talking about finding the slope of a tangent line, we need to use the derivative function, and we use this notation here to say we're going to take the derivative function, we're going to evaluate it at x equals 3. So it just means that we're going to substitute our x value 3 into our derivative function and get the value for 6. So this is the slope of our tangent line. And so for our equation of the tangent line, we have something that looks like this. We just need to find the y-intercept now, and the way we do that is we take our point and we substitute these x and y values into our point, find our slope-intercept, and then substitute that back into our equation. So this is the equation of the tangent line through this point to this curve. So go ahead and try that with this function. Pause. Okay, the process is simple, not simple, but similar. So we take our function, since we need the slope, we find the derivative. We evaluate that derivative at our x value of our point, -1, and we get this as our slope. So the tangent line of our slope, of our the equation of our tangent line looks like this. We substitute our values for our point into this equation to find the y-intercept. And so the equation of the tangent line to the curve at that point, -1, 1, is going to be this. Now let's talk about a normal line. The normal line is the line that's perpendicular to the curve at that point. And so if we look at this graphic, our function is graphed here in black lines, and our point is indicated here, -1, 1. And so this green line is the tangent line to the curve at that point, and this red line is the normal line. So it passes through this point and is perpendicular to the tangent line and the curve at this point. So our job is to find the equation of this normal line. Okay, take a moment to see if you can figure that out on your own. Press pause. Okay, the process is nearly identical. We need to find the slope of the tangent line first, so here's our derivative function. We evaluate our derivative function at x equals -1. We find that this is 2. And then I invented this little notation here that the slope of our perpendicular line is the negative reciprocal of the slope of the tangent line. So if our slope of the tangent line is 2, the negative reciprocal is -1/2. So the equation of our normal line is going to start looking like this. Then the rest of the process is the same. We substitute x and y, we find out our slope-intercept, and then we substitute it in. So this is the equation of our normal line. Here is our final example, and we're going to bump up the difficulty a notch. What we're going to do is we're going to find the normal line to this curve at this point. And as it turns out, this normal line will intersect the curve again at a different point, a second point. So find the coordinates of this other point. Well, the first thing we need to do is we need to figure out the equation of the normal line. So we follow the same process. Here's the derivative. We evaluate it at 3. This is the slope of the curve at that point. The normal is perpendicular, so we find the negative reciprocal. We begin our equation here. We find our slope-intercept, and so here's the equation of our line. Now, if you recall, when you solve simultaneous equations, what you're doing is you're trying to find all the points where those two curves intersect. And so here we have the equation of the normal line, and what we need to do is we need to set this equal to the original curve. So our original function is here. So when we set these two equal to each other, we're finding the points where these two lines or curves meet each other. And so what we'll do is we'll move all these terms over to the other side with the x squared, and we'll make it equal to 0. We will use the quadratic equation or your graphics calculator to figure out the solutions, and we find that there are 2 points. One of them makes sense. The x value is 3, and that's the point that we already knew. The other value here is the value of the other point. So that's the x value of that point to this curve. So if I know that x is negative 19 over 6 and then I square it, that should tell me the y value. So the coordinates of the second point is this beautiful looking point here. You can tell I invented this question, so it doesn't come out nice and neat, but the process is what you really need to know here. So that's the equation of the tangent line and the normal line.